I can give you a clue that 1% more efficiency gives us 5, even 7% more of LCOE. And we move on to the next step. And now we are focusing on different technologies in models. We try to compare them and give you a clue which technology will be best for you and, of course, for your customer. So let's move on. When we're choosing different models, we are looking which we expect from the models more and more, and what exactly we expect more. We expect higher efficiency because thanks to that we can put the same more energy in the same space to spare the same place, get more power. I can give you a clue that 1% more efficiency gives us 5, even 7% more of LCOE. So it levelized cost of energy. So when we increase efficiency and spend less space for the same amount of energy, we increase levelized level of cost of energy, which is overall cost of buying, investing, and service devices divided by the energy which it produces over its whole lifetime. So that's why efficiency is so crucial, and that's why we look so badly on that factor. Also, we are interested in increasing energy output because if in one frame we can put more power, we have to put less models, less labor, less construction, less protection is provided, so the overall cost of investment are dropping. Third thing, which is quite obvious, is reducing cost per watt, because to reach lower and lower LCOE, which is our goal, is we need to reduce cost per each watt. And at the end, we believe, all of us believe, that PV models, sun energy is the most environmental friendly, so we also have to reduce carbon footprint, because there is the point is not to produce carbon in one place on the world to save it in the other place, but the point is that the whole world can live lower carbon footprint. So that's what we expect from the models. That's what we expect from evolution and developing PV industry. So the main popular technologies which are today available is p-PERC, TopCon, heterojunction, shingled, thin film, and different kind of back contact models. But in real life, actually, in mainstream are 4 technologies. Those 4 technologies, and we look closer and compare those 4 technologies, because one of them is the leader right now and will the leader in the future. So during the years, we saw that P-types was the main technology which was provided by manufacturers, but last year, 2023, shows us that it's not enough, that this technology is reach its potential, so different, better technology shows up. And last year was year of TopCon, which shows quite strongly in last year, and we expect in 2024 it will become the leading technology. And today I hope I will answer you why. It's not something new and unexpected, but it's something which comes to mainstream. So let's start from basic technology, which still is p-type PERC technology. Most of us started PV industry with p-types because they become popular and mainstream technology in 2019, and it's still the basic technology for all of us. It's a definition of PV modules because of their reliability, good pricing, quite high efficiency. Thanks to that technology, PERC technology, p-type PERC technology was grown enough to show the world that we can switch to the PV as a source of energy for the whole world. And this technology is built like that in middle of the silicon, is dropped with gallium or with bore, and it leads us that the main part of the model is positively electrically charged, and it goes driven current flow direction. Why it's important? You will see in a few slides. So the pros of this technology, for sure, it's Hakuna Matata technology. Everyone knows that there's plenty of manufacturers, great competition, great quality product, good pricing in that product, and there is no unexpected problems. We tested and used this technology so widely that we know it quite well, and nothing unexpected will not happen. But its potential has exhausted, because last significant development was made 2 years ago in 2022, when it reached its maximum efficiency, and that technology ended. So it's good technology, very well tested, but 2 years in PV industry, it's a century. So its time has come. It's still the most popular technology, but its days are counted. And the new champion, which shows up on the market in 2023, shows this is it. That's the time. It's N-type TopCon technology. It's built almost the same, very similarly than P-types, but it's dropped with different mineral. It's dropped with phosphorus, and it leads us to the different energy flow. It's like right hand and left hand. It's that similar, and it's road, but it leads us to some significant changes. Present efficiency of that technology is already 1% higher than the best P-type models. So in the beginning of its road to the success, it's already in better start position. It's relatively easy to upgrade from P-type to N-types, because silicon waffles are so similar, the technology of making models are so similar, it's relatively easy to adjust, to upgrade old manufacturing line, assembling line, to the new technology. So we don't have to build new factories to use better technology. That's why TopCon is the next leading technology, because it has better parameter in every matter, and additionally it's quite easy and fast to put in the mass production. So better in every parameter. What does it mean in real life? So we said that TopCon is better in every parameter that P-type. So what are the real differences? First of them is degradation in time. P-types losing more or less 2% in the first year and about 0.5% every next year. TopCon is better because phosphorus, which is dropped into the silicon, doesn't react with oxygen, and it's free from lead effect. Thanks that in N-type TopCon models, producer gives us better warranty for 30 years, not for 25 years, like in P-type models. And additionally, after 30 years, we have even better efficiency than N-type technology. As you can see, the difference is small, but it exists. The another thing is power temperature coefficient. It's only 0.06%. It's a small difference, but for each the degree in Celsius. So like models are tested in 25 degrees, it's standard test condition, STC. Then in real life, when the sun is shining and the production is maximized, the models actually are very hot. They reach like 80, 85 degrees in real life. So it means that every single better handling with the higher temperature, increasing significantly production of the models. So if we take exactly the same model with the same initial power and we increase temperature, so we put in normal life condition, then N-type will produce about 3% more, thanks that just power temperature coefficient. And it's worth to mention also about better bifaciality factor, which lead us to better production when we use bifacial models and when we use bifacial effect. Depending on the surface below the model, the increased production is 3 up to even 4.5% additionally. And thanks that TopCon already has an experience in real life, we can not only see charts how good, how better they are, but also we can see the real adjustment in different plants in different area around the world, because we have already real experience with TopCon models. And as we can see, thanks to better parameters, we can reach 2, 3, 5% more of production, depending how the average temperature is in the area when we make this tests. So when we compare p-type and n-type, p-type are in last position without doubts. That's the present situation. In the future, Jinko, top manufacturer of TopCon models, sustain that in this year they can reach additionally 1% more of efficiency, because it's mainstream technology, is the most developed technology right now around the world. So in the close future, cell efficiency can reach even 27%. If we add frames, if we add gaps between cells, the models should reach efficiency like 25 and something, a little something % of efficiency. What does it mean for you, for an installer? Models, 108 cells, the most typical domestic models in p-type technology, reach power like 410, 415 maybe power of watts today. N-types already in the same size of frame, in the same surface, reach 435. If those predictions will be valid, in next year we will have model 490 watts with the same size. So that's the future of TopCon, the most developed technology right now. But it's not the only interesting new technology which hits the market. The next one is N-type heterojunction technology, and the competition between those two N-types technology is something which is good to be aware, because again, because of the differences of the technology and parameters. Heterojunction are quite similar to N-type models because the basic are the same, but on the surface of the model is additional TCO layer, in most cases made by thin film silicon, thanks that making the sandwich of different technology of cells, this product, this cell can reach another level, another 1% more efficiency, and even better parameters than N-type TopCon. And it's just the beginning of the road, because heterojunction is advanced developed, it's already available, right? But they are not developed so good than TopCons. So here place for development, for adjustments are higher. And again, parameters, the differences of the models. As you can see, if N-type is better than TopCon, then heterojunction is even better, having even better parameters with excellent linear degradation, with power coefficient temperature, and heterojunction has the best parameter on the market right now. And if we compare most closely installation in the two technologies, which is p-types, the basic technology, and let's call it best one, heterojunction technology, in specific situation, that's of course data reached from producers who are trying to advertise heterojunction. And those data are true, but made like look the best as it can, but still they can reach 30% more production from the same area, from the same initial power. In my opinion, it's a quite significant. And something which is good to mention, because we sell about parameters, but models, it's not only parameters, it's also real-life uses, and durability of the models is something interesting part. As you can see, one of the heterojunction producer tested their models. Thanks that heterojunction have to be thinner, it means it lead us to way higher durability, to way higher flexibility, and can survive way better than any other kind of models. I think this picture visualizes it better than I say it. So, how it works in real life? Actually, we don't know. The data which provides to us producers, they are just simulations. Like TopCon are already testing in real life. Heterojunction is still too new technology to be used widely. So we have only simulation. How better will these plants work? This farms works if we switch the p-types to heterojunction. So we don't know real life condition. And when we can see the advantages of heterojunction, they are amazing. Waffle is cheaper thanks that it's thinner, like Marcin Zienkiewicz said in his presentation. That's the chance for the industry. And in most areas, the technology has better parameters, and it's easier to make in mass production environmental friendly and cost friendly product. But the challenges which has this technology, as you can see in this draft, is almost 20%. 20% price of the model is using silver. It's very raw material, and additionally, it's expensive material. So that leads us to the high price right now, and heterojunction producers want to drop the prices, decrease the prices, for example, by lowering containing of silver. And one of the leading heterojunction producer has this plan for this year that they can reduce about 10% using silver in their models, and it decrease prices and increase production capacity of that kind of models. It looks nicely on charts, but this technology is still so young that all adjustments, especially replacing materials inside building of models, might cause some troubles which we cannot see today. So technology is very promising, but how it develops, times show. And it's not like p-types, we know that perfectly and we don't worry about anything. Parameters are exciting, but be aware, it's not without any costs, and not every cost is in money. Okay. Fourth technology which I would like to present to you today is N-type or generally back contact technology. And why it's so interesting? Basically because it's side technology. It's existed since years and years. Only one manufacturer in the past developed this technology in real life. Models was always the best. Back contact models was always the best without any doubts. But it was 3 times more expensive than any other technologies. So it was always side, turbo effective, but side technology in our industry. So right now, best back contact models reach another 1% better efficiency, and they are better in every parameters than competitors. They look better because in the front of the model you don't see bus bars, because everything is hidden behind, and the positive and negative electrode are in the back of the cell, so you don't see it at all. It gives us additional advantages. First of them, if there is no bus bar in the front of the model, it doesn't take surface, which can be covered with sun, which can consume sun. Thanks that, according to producers, it's not only the line which is bus bar, but also shadow made by those lines. And producer says it gives us additional 2.5 production rate thanks to that effect. And additionally, which is even more important, bus bars are in Z shape. When we have bus bars, they are in straight line. It means that modules are way more, the durability of the modules are way better, and they can survive even 3 times more to be cracked a cell or a connection soldering between cells than any other type of technology. So that's why that's the best technology, and thanks to that also degradation is slower. So it's leading technology, no doubts. And today we have 2 interesting division of back contact modules. First of them is EBC or ABC, depending which producers make those. The gladiator, the absolute leader, shark of the market, best technology, no doubts. True, okay? The warrior which wins every fight. But we have also a mystery player, HPBC. Interesting technology produced only by one producer who mastered p-type models, because they took p-type cells and used back contact technology to connect cells. So they used, let's call it old technology, those which we dropped exhaust as much as we can. They mastered the technology and use it with the best way how to connect modules. It gives us completely new idea, new quality of p-type modules. According to their tests, to their simulations, they can give additionally 10% of production. In real life, I don't believe it so much, but the idea is interesting, and times show how this technology will hit the market. Additionally, back contact technology better handled with shredded light. So as long as strong light, both modules produce with full efficiency. That's okay, that's true. But if the light is smaller and smaller, especially in the beginning of the day and at the end of the day, in the morning and in the evening, there's less light, and back contact modules can handle with it better. About EBC, ABC technology, I showed the comparison of main parameters. The main parameters which, in my opinion, are interesting, the actual power of module with the same size. If we take 108 cell module, right now ABC modules can provide 465 watts of power, TopCon 430, I heard 435 will come along, and 410, 415, it's the maximum. You see the 50 watts of differences. 1%, 2% in efficiency give us 50 watts in power. That's quite a difference. And other parameters are also better in ABC technologies, like power coefficiency, degradation, and power density. If we compare all types and producers of different technologies, we can see that back contacts is leader without doubts. Heterojunction are chasing them. TopCon, which is new mainstream technology due to capacity production and prices, are just after that. And at the bottom of this scheme, we see p-PERC technology, which is not developed at all since last years. Okay, so if we compare parameters, we can see that no doubts ABC technologies are the best. The pricing are significantly higher. So it's best product, no doubts, for most demanding customer, but for mainstream products, probably next year TopCon will be the leading technology, and have to look back for heterojunction, which for sure will chase them. So if we summarize that, P-type is that its time has come, N-type is chasing them, but at the end, if back contact technology price will drop, it will swallow all the rest of the technology. And the future of our market, what happens next? We slowly reach maximum potential of silicon technology. Why? Because silicon modules can absorb only visible light. And we are reaching the spectrum of light which we are hit from the sun. Only about 30% is visible light, and we are closely reaching this technology, reaching this level, and reaching the limit of the silicon technology. So the next step, producer says that they will not develop silicon technologies, but start to create tandem modules. One layer of module will absorb different type of light, like ultraviolet or infrared. Different layer will absorb visible light, and thanks that we can exceed higher efficiency of the modules up to 40 couple %, but it's way for future. But right now, producers expect that the future that we will expect. So what's the future? Who knows? It's a mystery. I don't have glass ball. I don't give you straight answer. I just want to provide you an information to give you a best awareness where we are right now and what we might expect in upcoming year. That's all from my side.